And there we go. I'll keep an eye out for a few more, probably. Okay, well, that was, I know, challenging test yesterday. Some of you did have some issues with time. It's unfortunate. Best thing you can do is to have turned in your scratch work, and I will look it over. And if, you know, even if you didn't complete a problem in MOM, if I think it's appropriate, you know, I can still give you some credit if you've worked out problems in your scratch work that I can look at. Okay, had I'd say, yeah, a wider range of scores on this one. Some of you did very, very well, and then of course, yeah, especially if you ran out of time, the scores kind of reflected that. So I'll get to that this afternoon. That'll be my job, sitting around just after lunch probably, and probably middle afternoon you ought to be able to see those grades. Okay. I would actually like to talk about schedule a little bit for a minute. All right. And I'm going to do that share thing where I'm going to share my computer screen, see if I can pull that up. And let's see, what do I want? I want that one. And there, you should be looking at my computer screen right now and see a copy of our class schedule, right? And I've made some adjustments. Just, you know, here was that day where I was sick, and we bumped the test back from Monday to Tuesday yesterday. And so that kind of, you know, bumped us a day behind as far as starting our next chapter. If you recall, the schedule up until I changed this one had our final on Wednesday. That's kind of like leaves me room to do this, move it all to Thursday, right? So the idea there, let's see if I admit this person. So here what I've done is, you know, bumped everything over the one day that basically I had to move it over because of my being absent. And so this test was scheduled for the Thursday. So here I moved it to the last week on that Monday. Then there's just 2 days dedicated completely to reviewing for the term, and then the final on the Thursday. So otherwise, we probably really would not have met at all on that Thursday. I might have been available for questions or something like that. So at this point, I'm just asking you to think about that, whether that causes any problems for you schedule-wise. And, you know, I know that means coming back on a Monday and taking a test. And, you know, which is, I guess it's nice to avoid that if we can. But I think this might be a good accommodation, whatever the word is, compromise. Okay? So, you know, get back to me and let me know if you see any issues with that. Okay? All right, so there's that. Back to. Can
you show that one more time for me, please?
Oh, you want to see that again?
Yeah, one more time.
Would it help if I just posted that in the forum? But I could do that. Here we go. I'll just look at it one more time. Ta-da. Sure, no problem. Yeah. You know, so here we are on Wednesday, right? It's Wednesday. And we've got one more unit. Almost done. So really there's 4 different sections in this chapter. The last section, 5.4, is applications, word problems, you want to say. And so, you know, I've definitely left a couple days for that, and then still a review day. So, is that good enough?
Thank you. Yes.
Okay.
Thank you.
Yep. All right. Well, I know you would, perhaps some of you would like lines to go away, but they're not. In fact, we're doing 2 lines at the same time in this chapter. So that's what's known as a system of equations. If you have 2 different sets of conditions that are operating on a situation at the same time, You could have one equation that describes the one set of conditions and another equation that describes the other set of conditions. And our job is to find that point that satisfies both of those conditions. You know, what's going to satisfy both situations. I'll make up one here real quick here that kind of describes an example, okay? Systems are actually very real things out in the real world. You know, you think, we use that word system, like all the different parts of your car that have to work together as a system, you know, to make it work. In manufacturing, there might be several different layers of considerations, you know, that have to be taken into account to develop a certain process or something like that. Just as an example, for instance, let's say a company develops a product, and we might have written an equation, say, maybe they spend $1,000 in development, right? And then they're going to charge, it costs them then maybe $50 a piece to make the particular product. So I might say their cost is 50 times each one they make, plus the $1,000 it took them to develop it, right? There's a mx plus b shape equation. And so you might get a line that looks something like that, that describes their cost for each one they make. Of course, their costs go up. Well, then they've got to sell it and make money, right? Revenue. So maybe they decide to sell it for $100 a piece. And if they sell none, they make none, right? But that's a steeper slope. How many do they have to sell before they start making a profit, overcoming that initial cost? You know, so that line is doing something like that. We're looking for, that would be called their break-even point. You know, where do those two lines intersect? That's going to be the, as far as this story, the point where their revenue matches their costs, and any more they would sell past that would allow them some profit, right? Whatever this amount up in here is, some profit. So that's that point that would sort of satisfy both conditions, right? So this is a picture, a graphic representation, of course, of what we're going to be doing in this chapter, finding that point that satisfies both of these equations. And so it's got to be a point that, of course, is on both lines, right? All right, well, in our next couple of sections, we will have algebraic techniques, ways to manipulate the numbers to come up with that point. But our first section, much like the first section in the last chapter, is just finding solutions by graphing those lines, just like I did there. We're going to have the lines, the equations, excuse me, we're going to have our equations. We're going to have to graph the equations and then look for that point where those lines cross. And that's going to be the solution point to the system. Begin with, though, again, like kind of like the beginning of last chapter, we want to verify, is this point a solution to the system? So we're going to see a lot of our equations in that other form in this chapter, more than we did in the previous chapter. We're going to mix them together more. So here, and often when you're looking at a system presented, you know, in a book or online or something, they'll brace the two equations together, implies that those two are working together as a system. Let's get Gwen in here. Good. So anyway, just by the way, I'll definitely write that up. The schedule thing I mentioned, I'll write that up and post that in the forum so you can refer back to it. Anyway, these two equations represent some situation where there's two different conditions happening at the same time. Well, so to verify, we're looking for a point that makes them both true. It's got to make both equations true. So here's a question. Is the point 2, -1 a solution to the system, you have to plug it into both equations. Or actually, if you plug it into the first one and it's not true, then you're done. You could say no. But you've got to test it in both equations. So I'm going to plug that in. I do a lot of this arrow stuff here with these systems. So for that first equation, if I put in 2 for the x minus a -1 for the y, does that get me a -1? Well, that's 2 plus 1. That's not -1. So I guess right there, I know that that one was not a solution. It didn't satisfy the first one. Maybe it worked in the second one. I just chose the first one. Well, all right, how about maybe this point? These are just, a problem would have to give you a point or two and ask you to verify or test it. We don't know where these points came from. All right, so I'm going to test that one. All right, so first one again, -4 for x minus a -3 for y. Does that equal -1? Yeah, it does. For that first equation, this is definitely a solution for that first equation. All right, so now I've got to plug it into the second one. And I think I'll see if I can squeeze that in over here, okay? So 2 times my x value minus my y value. Look at all those minuses, right? And then equals -5. You see all that? Yeah, okay, so here I get -8 plus 3 supposed to equal -5. Yep. So it's a solution to the second equation also. So yes, this one is a solution to that system. And really, think about straight lines. If they cross, it's only going to be one point. There's only going to be one solution. If those are two different lines and they cross someplace, right? So yeah, that is the one solution to the system.
I have a really quick question.
Yep.
So if one, like the one before, if it doesn't equal the first equation, then you don't plug it into the second equation?
Well, you already know it doesn't make the first one true. So you don't really have to test the second one. Even if it made the second one true, it didn't make the first equation true. So it can't be a solution to the system. It wasn't on both lines. It was only on one line maybe.
Okay.
Does that make sense?
Thank you. Yeah.
Okay.
Thanks.
Yeah. So it's kind of like, oh, you got lucky. You could stop after the first one, something like that. Right? So that's what we call our verification process, okay? Take the points that you're asked to test and plug them in to both equations and carefully simplify and see if you get a true statement. All right. All right. Well, get my other page of notes here. Oh, so I'm going to erase that. We're going to solve some systems by graphing now. In this first section, I think maybe there's one last problem in MOM. In 5.1, that's kind of an application. I looked at it. I think hopefully the situation's easy enough. You can write those equations, come up with the equations. Not a whole lot of that yet, all right? We're gonna be giving you the equations to graph yourself. That's gonna be your challenge. You gotta graph them. I'm gonna try to work over there and write stuff here, so. 3x plus y equals -3. And, well, that's, oh, well, 2x plus, I'm wondering, was this really my first page of notes? Got to do more work than I want right away. All right, so here is a system, 2 different equations. Let's graph it and look for that point where those 2 lines intersect. Well, so you've got to pick your favorite way to graph. Depending on the equation shape, you might choose one method or another. So those techniques that we used last chapter, we're trying to apply. Now, both of these are in that ax plus by, x and y on both on the one side form. And here's where I would often say the intercept method might be a good choice. You know, can I do this thing for one of those equations and plug in the zeros? All right. The 3 and the 1 would play nicely, you might say, with that -3 here. So I'm going to try to use this intercept method here, okay? And like I say here, I can show my work now. If I put in 0 for x, right? 0 plus y is -3. So when x is a 0, there's my ordered pair, 0, -3. This is my y-intercept value, okay? If I put in 0 for the y, right, I get 3x plus 0 is -3. That's just going to go away, right? Divide by the 3, x is -1. There is another intercept value, ordered pair, -1, 0. So there I have 2 points for that first equation. Now on graph paper, carefully draw those lines. All right. There's just the first one. All right, now I got to do that, something like that for the second one.
Well, I'm confused as to why it's a 3x when the equation was a 2x.
I'm completely working with this first equation.
Okay.
Yeah, I was trying to find 2 points for the first equation. A lot of work here, right? I found the two intercepts just for the first equation. Yeah, that was all. Okay, does that make sense? Does that help? That work? So, but now I'm going to try to do, you know, graph the second equation. Okay, if I erase this, let me know. Catch me quick. Here goes. Make myself room again. Now looking at this equation, oh, if I divide it by 2, if I put in a 0, I'd have to divide by 3 and get a fraction. So these numbers don't really work nicely. Really, how did I come up with that example, Steve? All right, okay. I'm gonna rearrange this one. I'm gonna solve this one for y and put it in that other form. I think I'm still gonna get a fraction. Shoot, what did I do? Where did I find this one? Subtract the x's. Okay, I'm just working with the second equation here. I'm going to subtract the x's, so I leave 3y is -2x plus the 5. Now I'm going to divide by the 3. I'm still going to get a darn fraction over here. Y equals -2/3 x plus 5/3 is 1 and 2/3. That's annoying. But now I see the slope and I know the intercept. That's just going to be passed. 5/3, 0, 5/3. All right, 0, 5/3, 1 and 2/3. I'm going to make a note here to change that example for the future. All right, 0, 5/3. Now I got to work from that point and go over 3 and down 2. I'm going to go over 3 and down 2 for my slope, okay? So I apologize, 1, 2, 3, over 3 and down 2 is going to make me just like a third below the axis, estimating the fractions. But there are those 2 points. And graph that second line. I'd like to say, I don't think you'd have to run into bad fractions like that. Well, so with the coordinates of that point. And here's where you get to count your grid. -2, I know the solution because I worked it out previously. -2 and 1, 2, 3. There is the coordinates of that point where those 2 lines cross. At least the fractions didn't get in the way at the end. aside from the fraction mess, this is the technique that you have to use. You got to find ways to graph both lines and then look for that point where they cross. Let's look at
The point where they cross is called the system.
This is the solution to the system.
Okay,
Okay.
thank you.
Yep. Solution to the system. All right. Just do it again, okay? I'm going to erase that, okay? Here goes. Looking at my notes again. And yeah, this one's better. How about x minus y equals 3 and 2x minus y equals 4? I would just say in general, when they're in that form, consider using the intercept method. Will it work nicely without getting messy numbers, fractions or something? In this case, it would for both of them. So first equation again. I'm going to do it this way. I'm going to plug in those zeros. All right. So here I go, right? 0 for x. Negative y is 3, so y must be negative 3. They're kind of cheating. There's my ordered pair over there. All right. Same, first equation, right? Well, I don't need that again. First equation, but I'm going to now put the 0 in for the y. So x equals 3, that just goes away, right? There are the intercepts for that first equation. 0, negative 3, and 3, 0. 1, 2, 3. And I'm going to draw that line, make sure I don't confuse it with whatever else I do after that for the other line. All right. I'm going to erase that and then work on the second equation, okay? Here goes. And I'll erase all that. And we'll do it again. X, Y, yeah, both of those numbers are going to work well with the 4, so I'm just going to use this intercept method again. So, second equation. 2 times 0 is 0, minus y equals 4. So negative y is 4, so y must be negative 4. Felt like I went kind of fast there. Hope that was okay. Okay. Putting the 0 in for the y, still the second equation, right? 2x minus the 0 is 4. Just ignore the 0, right? Divide by the 2, and I get x equals 2. So when y is 0, x is 2. So there are the intercepts for that second equation. 0, negative 4, and 2, 0. Oh, it's going to cross right in there someplace, huh? And so here I go with that line. So now you got to read your graph, count the squares, and find that point right there. And 1, negative 2. Yeah, just again, double checking my answer because I don't have the graph grid, but 1, negative 2. That looks pretty good here. Is that solution point? Make it big enough for you. Too many big dots there, close to each other. Graph both lines, look for where they cross. Do it again, okay? Just gonna keep going like this today. We'll get to some special cases eventually here today. All right.
Can you do one more just like this?
Okay, with the, sure, that uses the intercepts. The next example was gonna be 2 in the other shape, but yeah, let's go ahead. And Find one with good numbers here, okay? How about negative x plus y equals 2. That's the same. Is that the same one I just did? Sorry. No, it isn't. Okay. And how about 2x plus y equals 4? You want to give it a try and I'll wait for you?
Yeah.
Yep. All right. So I would, if I could prompt you here, just look at it, how the numbers work together. I think the intercepts would be a good choice, a good way to graph those two lines. Is it okay if I do the first equation intercepts? Okay.
Yes.
All right. So, and maybe I'll just, if I put in a, here I do my eraser math here. If I put in a 0 for the x, I get y equals 2. If I put in a 0 for the y, negative x is 2, so x must be negative 2. And there are the two intercepts for the first equation. You okay with that? I'll let you keep going, do the second one. Of course, you want to put those on the graph and draw your line, right? I'm going to draw that line, okay? Not too messy. You ready for the second one then? Can I do that yet? Any issues? All right. The second one, if I put in a 0 for the x, that goes away, y equals a 4. If I put 0 in for y, 2x is 4, so divide by 2, I get x is a 2. I didn't show all my work. I was hoping that was easy enough numbers. How else to say that, okay? Any issues with that process? So now there's the intercepts for the second line, 0, 4, and 2, 0. I always find myself stopping, make sure I've got the right axes, you know, doing lots of intercepts, make sure I get them in, get the right one, the right place, X and Y, right? All right, connect those two dots. And I'm guessing from my graph that maybe it's 1, 3. Is that what yours looks like? Yeah, 3 minus 1 would be a 2, and 3 plus 2, whoops. Oh, 2, no, 2 plus 3 adds up to 5. Oh, did you get something different? Did you get a fraction? Maybe my...
So I'm good up to the point where I figure out my points on my equation like you did, where you figure out the intercepts. I'm confused where we go from there. I mean, I get that we're plotting the points, and I see that it crosses at one certain point on the graph.
Yes. And so now I have to figure out the coordinates of that point. I'm counting the squares. You know, like it looks like maybe the x value is a 1 and 1, 2. I thought I graphed it pretty well, so it looks like not quite 3. Does it look like a fraction spot on your graph?
I think that's where I'm having trouble is with my lines. It's not always adding up to like a perfect point when I draw it out myself, maybe. So I think that's where I'm having trouble. So,
and this was not one of my pre-chosen examples that I expected to work out nicely, and you know, hoping I didn't. Oh, I see what I did. The problem I was trying to copy had a -4. It probably works out really nicely if you use a -4. I copied the problem wrong. So this one looks like it does kind of intersect in some fraction spot right there. And just because I copied a problem works out that way. You won't run into that, okay? You're going to run into problems that have nice intersection values right on the lines. If I was to redo this one, if you would like me to redo it right now, we'll get a nice answer. If I put in a -4, like the problem I was trying to copy had asked for, I'd get y equals -4 and a -2. All right. And so that would have looked like 0, -4, 1, 2, 3, 4, and -2, 0, oh, right there. Ha. All right, that's what that problem is supposed to look like if I put a -4 in there instead of 4. And there, now it's pretty clear, hopefully easy to see that that is -2, 0 is that intersection point. Well, I tried to do one more for you, sorry. Does that help? I mean,
I'm going to replot it right now and see if it looks a little bit better.
You know, it points out the limitation of the graphing technique for these problems. Unless it turns out to be nice integer, you know, whole number values, you're guessing when you're reading the graph. Who knows what that fraction might be? You know, there's an infinite range of fraction values it could be. So your graphing problems are going to work out to be nice numbers in this first section, okay? Maybe that's, you know, if it doesn't, then go back and look again and see if it, maybe you made a mistake someplace, like I did.
So, sorry, before we get any further, what would that point of -2 and 0 be called? Like, what would be the term for that?
Oh, this is the solution to the system. It's the
Solution to the system. Okay, thank you.
So system, we have multiple equations. We're looking for the one point that is a solution to all the equations. We're only going to deal with 2 equations. There are systems with many, many equations. Don't worry about that. Yes, the solution to the system is that point. Okay. Thank you. Let's get back on track here, okay? And time-wise, we're doing okay, yeah. Good. So you're going to see equations in both the different shapes that we have worked with. So how about this one here? Y equals 3/2 x plus 1, and y equals -1/2 x plus 5. 2mx plus b shapes. I would hope you would find the intercept and use the slope to graph it rather than needing to build a table of values. But you can build that table of values if you want. Plug in some multiples of 2 for x, see what you get. But you might get a head start on me, right? I'm going to graph that first equation. Y-intercept of 1, 0, 1. Now I'm going to start from that point and use my slope. I'm going to go over 2 and up 3. All right? Over 2 up 3, 1, 2, 3, and the neater I can be, the better my graph point will turn out to be. There's 2 points for that first line. Going to do the second one the same way. Y-intercept of 5, 0, 5. 1, 2, 3, 4, 5. And negative slope. So I'm going to go over 2 and down 1 for my slope. Okay. From that starting point of 5, I'm going to go over 2, 1, 2, and down 1 to there. Kind of see what's going to happen already, right? And just by chance, turns out that point that I used to plot the first line is the solution point. All right. What is that? That looks like, is it supposed to be 2, 4? Yeah. 1, 2, 3, 4. I'm thinking maybe maybe that really was that point right there to begin with, and it didn't work out nicely on my graph. Does it look like 2, 4 on your graph? I'm going to say, yeah, that should have been over here. Looks like that first line maybe.
Okay, so when we're given something like this, we're not going to plug in the intercepts like the last one. We're just going to use our slope and our y-intercept to plug in the plot points, correct?
I would encourage you to do it that way as a easier or faster way if it makes sense to you. And if you get confused about that, here's that other technique was, pick some nice simple x values and maybe multiples of 2 would have been nice numbers to plug in for x. You can choose which way you feel most comfortable with. But yes, I'd like to think that using the intercept and the slope is an easier way, a better way. Okay. If it's in this shape, yes, I would try to do it that way. My suggestion. Okay. You do another one of those. All right.
So sorry, real quick. When you have a slope of 3 over 2 x plus 1, are we starting from the point of 0 and going up 3 over 2?
No, you always have to work from a known starting point. So here I started.
So you start from your y-intercept of 1.
Yeah.
Would you plot that 1 as a point?
Well, that's the y-intercept is 0, 1. We know that point on the graph, right? That's what mx plus b.
Okay, that's making more sense. So from that plot point, then I would go up 3 over 2, make my second plot point.
Yeah.
I see. Thank you.
Okay. Yeah, all that stuff we did last chapter, these last 2 chapters are really the focus. Ideally, the focus of this course is getting to these last 2 sections where we're doing all this work with equations for lines.
Can you give us another one like this, please?
Oh, absolutely. Yep. Here we go. And how about y equals x minus 2 and y equals negative 3x plus 2. How about shall I wait for you? Okay. Yep. Okay. I think first thing for either of them is you to recognize the y-intercept value. 2 different, I almost don't like to do both of them at the same time because they're for 2 different lines, but anyway. Yeah, put your y-intercept on there and then use your slope. That slope is that unseen value of 1, right? 1 times x, slope of 1. which is the fraction 1 over 1, all right? Over 1 up 1. This one you'll want to make a fraction, like over -3 over 1. You got to make it look like a fraction to use that slope. I'm going to do the first line, okay? Y-intercept -2, 0, -2, ordered pair. And slope of 1 over 1 up 1. Gets me there. Got you there, right? And there's the first line, I think. Looking at my notes, looks like you end up crossing one of those points for the second line, huh? Same point, huh? Second line, right? Intercept of 2, 0, 0, positive 2. Y-intercept. Slope of -3. Write it as a fraction for yourself. -3 over +1 or vice versa with the negative, it doesn't matter. But if I go over 1, down 3. 1, 2, same point. Graph look like that, aside from my messy dots. And I think that looks like 1, -1. Did you get that point? That worked for you. Any trouble there? Okay. All right, here we go. Can I erase that one then? All right, is it good enough? All right, no quick questions, that's all right. All right. Y equals -1/4 x plus 2. This one's mixing them up. X plus 4y equals -8. So two different forms together in one system's problem. That could happen. First one I would graph using the intercept and the slope. The second one, I think I would put in the zeros, use the intercept method. That would be my choice. Otherwise, you could like rearrange that second one if you wanted to subtract the x, divide by the 4. Should I wait for you or you want to do it? Or should I do it, I said. I'll let you do it. Excuse me. All right. And if you're doing it yourself, I'll just tell you, it's weird. If it looks weird, something's wrong. If it looks weird, you did it right. Something very particular about this one. My intercept is 2. Negative slope. Okay, if I go over 4, I'm going to go down 1. 1, 2, 3, 4, and down 1 gets me here. Second equation, I would recommend the intercepts because they work pretty well. And here my cover up math here. X is a 0. 4y is -8. Dividing by 4, you get y is -2. And then if I put in 0 for the y, x is just -8. There are the x and y intercepts for that second line. 0, -2. -8, going backwards, right? -8, 0. 1, 2, 3, 4, 5, 6, 7, 8. All right, and almost drawn nicely. You get why this is weird. What are those lines trying to look like? Parallel. Yeah. What's the definition of parallel lines?
Lines that don't intersect.
Very good. It's like an old geometry question, right? Two lines that never intersect have to be parallel, or that's the definition of parallel. How many solutions to the system then?
Zero, because it's not, no solution because there's not, no intersecting.
Exactly, right. So if this happens, there is no solution.
So am I to understand that when it's given in slope intercept form, like the first one, the y equals -1/4x + 2, we can easily determine our slope and our y-intercept, but when it's in more of like an equation form like the second one, that's when we're going to plug in our intercepts to get our points, because it doesn't readily give a slope and a y-intercept, correct?
Correct. If you wanted to rearrange this one like I did with my very first example and got a messy fraction, if you wanted to rearrange this and put it in that form, then you could use the same technique. But this is why I've tried to emphasize, well, just look and see, you know, if I have to divide by that number on both sides, is it going to give me a fraction or not? If it's not going to give you fractions, then the intercept method works very nicely. I think easier than rearranging it. Yeah, so this one, I would recommend the two different techniques for this one. Okay. That's sort of a long story to answer the question, all right? And, oh, well, look at that. All right, so we'll finish up with a couple more another weird one tomorrow, and then get into our algebraic techniques. We've already.
I have one last quick question. You'd said in our homework we should not come up with fractioned intercepts.
Well, if you think you did, I'll go back and double check. I'm sorry if that happened, but I didn't think you would. I thought the mom problems probably wouldn't do that.
I just emailed you one.
Okay, well, I'll look more closely at it.
Thank
then. I will. So, all right. And that's it for today. I guess we're out of time. But that's our basic approach, our technique. Here we ran into one where they were parallel, so there would be no solution. Just to mention, the other weird one is going to be one where they really ended up being the same equation. So there really only was one line, and that has any point on the line, an infinite number of solutions. The two equations might have looked different, but if you rearranged them, they actually turn into the same equation. That's the other unusual one. Okay, well, give it a try, 5.1, and I definitely will go look at that. See what kind of, and offer some suggestions if you really got a fraction answer on one of those. And I'll get those grades figured out and posted this afternoon. All right, folks, have a good day. See you tomorrow.
Thank you.